The second formula, 1 by 1 plus d, that can be written as 1 plus d whole inverse. That is nothing but 1 minus d plus d square minus d cube plus so on. Alternatively, plus and plus minus. The next one, 1 by 1 minus d whole square. That can be written as 1 minus d whole to the power of minus 2. That is formula 1 plus 2d plus 3d square plus 4d cube plus so on. The same thing. 1 by 1 plus d whole square. That can be written as 1 plus d whole to the power of minus 2. That equal to 1 minus 2d plus 3d square minus 4d cube plus so on. Another one, 1 plus d whole to the power of 3. That can be written as 1 plus d whole to the power of minus 3. 1 minus 3d plus 6d square minus 10d cube plus so on. The last formula, 1 minus d whole to the power of 3. That can be written as 1 minus d whole to the power of minus 3. That equal to 1 plus 3d plus 6d square plus 10d cube plus so on. Now, by using these 6 formulas, we can solve the particular integral 1 by f of d into x power k form. Very easily we can solve it. Now, this is the method 3 particular integral. Now, method 4 particular integral means q of x equal to e power ax is fixed. Means e power in place of e power ax, e power 2x, e power 3x, means it should be in that form, into v of x. Means once again, q of x equal to e power ax into v of x. Then the general formula for this particular integral, 1 by f of d into q of x. 1 by f of d into q of x is, it already we have taken one form, e power ax into v of x. Means if it is in that form, you can write e power ax outside of that 1 by f of d. When you are writing outside of the 1 by f of d, then replace d by d plus a. Now, for this particular integral, I want to write e power ax outside. This is the standard procedure. I am writing e power ax outside. 1 by f of d, means f of d can be written as 1 by f of d plus a into v of x. Again, you solve this particular integral by general method. By using previous method, we can solve it. Once again, q of x equal to e power ax into v of x. The formula is 1 by f of d into e power ax into v of x. Means e power ax is outside, e power ax into 1 by f of d plus a into v of x. You solve this particular integral by using previous 3 methods. This is nothing but method 4 particular integral. Method 5 integral. Suppose q of x equal to x power k into v of x. X power k into v of x. Method 4 is e power ax is fixed into v of x. Here x power k is fixed into v of x. In this formula, if x equal to 1 exactly, means what is the formula? The general formula for this particular integral is 1 by f of d into q of x. That can be written as 1 by f of d. Q of x is x power k into v of x. I am substituting here 1 by f of d into x power k into v of x. Means k equal to 1 here. Means k equal to 1 means 1 by f of d into xv. We have direct formula x minus f dash of d by f of d into v of x. Once again, the formula is x minus 1 by f of d into x into v, x minus f dash of d by f of d into v of x. You can solve this particular integral by general previous methods. previous methods we have four integrating particular integrals. By using those methods we can solve it very easily. Suppose if x equal to 1, we are using this formula. Suppose x is more than 1, means x power k directly. 1 by f of d into x power k into v of x. Then we can solve this particular integral by taking real part and imaginary part of the particular integral. That is 1 by f of d into x power k into sin mx is there, v of x is. Then sin mx, if you observe sin mx, then imaginary part of e power imx 1 by f of d plus mi, d plus mi into v of x. Suppose if it is cos mx, the formula is 1 by f of d into x power k into cos mx. Then real part of e power imx 1 by f of d plus mi into v of x. Then you can solve these two particular integrals by general method. While solving the problems, this is a little bit difficult, but while solving the problems we can understand very clearly in our examples. Then these are the formulas you have to remember. You must remember these formulas. Without using this technique we cannot solve the problems. This is very, very important. And last, method 6, particular integral. By general method, without using all these formulas also we can solve it, but while for rare problems it is not applicable. Sometimes it is very difficult to solve the problem. The formula is 1 by d minus alpha into q of x. 1 by d minus alpha into q of x. The answer is e power alpha x integral q into e power minus alpha x dx. This is nothing but inverse. By using inverse operator we can calculate the particular integral. These are the 6 methods. Means complementary functions are 5 types, particular integrals are 6 methods. By using 5 to 6 methods we can construct the general solution of the given linear differential equation of higher order. Now this is very, very important. If you know these methods we can solve the linear differential equation of second and higher order. Then another method is also there that I will explain you later.